Okay, so this is actually not section 4-2. If you've been keeping track, we actually skipped 4-2. We're going to move right on to 4-3, dividing rational numbers. I don't remember off the top of my head. Oh, yes, I do. It's counting outcomes. So it really does. I don't know why it's sort of in that section because it doesn't really make sense, but I don't know. I haven't read the book. So this is 4-3. If you're ever looking for it, dividing rational numbers. Oh, way too big. Woo. Okay. So we're going to start out just like yesterday. We're going to start with dividing decimals, making sure we remember how to do that. And then we'll look at dividing fractions. The rules, though, are still the same as far as the signs go, which makes this nice. Same rules as multiplication. So if both of your numbers are positive or negative, the answer is automatically positive. If the signs are different, the answer is automatically negative. So I will add just like multiplication, if signs are the same, answer is positive. And so naturally, if they're different, answer is negative. Okay, so that's important to understand the sign part of it. That's really the only like new piece. And then the old stuff is just remembering how do you divide fraction or how do you divide decimals. And I think you guys have learned dividing fractions before, haven't you? Or maybe not. I thought you did. This was the, if you've heard that phrase, keep, change, flip. That's what we do with the dividing fractions. So if you know that phrase that I'm talking about, keep, change, flip, you have seen this before. All right, so let's see if we can get through some decimals before lunch. So let me give you an example problem and we'll see if you remember how to do it. If I wanted to do something like 14.68 and I wanted to divide that by, let's say, negative 0.8, I don't know, whatever. Do you remember how to do this? If I don't say one more word, could you do that by hand?
But I know that you should make the decimal sign a multiplication sign. You said keep, change, flip.
Yeah, that's for fractions though. Yeah, with decimals, you can't really do it that way. Yep. Christian?
We're allowed to use calculators for this.
All right, let me remind you how to do this. First of all, let's handle the sign because that's the easy part. If I have a positive divided by a negative, what's the sign of my answer going to be? It's got to be a negative. So here, I'm going to put my answer in here once I figure it out, but I already know it's going to be a negative. So let me put the negative in there. Now I can kind of ignore the signs and just focus on the dividing part. So when you are dividing, whatever you're dividing by, right, that's called your divisor. I'm pretty sure that's right. Sometimes I get the words mixed up, but that's the one. Remember doing these like in this sort of house? You put the 0.8 on the outside and the 14.68 on the inside. Remember that? That's what you're looking for. And when you are dealing with decimals, you actually can't have the divisor be a decimal. So do you remember how you kind of like fix this? You can't have a decimal out here. So what I would do is if I need to move that decimal one place in order to get rid of it, I just have to move this decimal one place also. So I'm really going to change this into being 8 divided by 146, and then I move that decimal one place too. Do you see that? Let me use an arrow. You can't have a decimal out here, so you got to move it one spot. So if you move that one spot, you got to move this one spot. If I had to, oh, sorry. If I had to move it 2 spots, I would have moved them both 2 spots. I just can't have a decimal on the outside. The inside's fine, just not the outside. Then what's cool about that, once you have that part set up, the decimal that's there just comes right up to the top. That just stays. That doesn't move. And then do you remember the steps that you do to actually do the division? You go one by one. So I asked myself, how many times can 8 go into 1? Oh, it can't. So then I make it bigger and I look at the 2. I ask myself, how many times can 8 go into 14? How many whole times can 8 go into 14? Not quite 2, because 2 would be 16, so that's too big. So it can only go in once, right? So I put a 1 up top, and then you do 1 times 8, and you write it underneath. Do you guys remember this? Now that I'm kind of doing it, so 1 times 8 is 8, and then you subtracted these 2 values. Remember that? So 14 minus 8 is 6. And then do you remember what's the next step? Oh, sorry. I realized we were a little bit off. The next step is to bring down the next number. And then you ask yourself, how many times does 8 go into 66? 8. So I put an 8 up top, and then I multiply. 8 times 8 is 64. And then you just keep doing this process. You're going to subtract 66 minus 64 is just 2. And then you bring down the last number, which is an 8. And then ask yourself again, how many times does 8 go into 28? How many times can 8 go into 28? Too high. 8 times 4 is 32. 3. So 3 times 8 gets me that 24, and then I minus, I get a 4. Now what happens here? If sometimes this number will end up being a 0, and that means you're totally done. Since I don't have a 0 though, what you can do is you can add a 0 and keep going. You can add as many zeros as you need to. So if I bring down another 40, and now we get lucky because how many times does 8 go into 40? 5. And it goes in perfectly. So when I do this last one, 5 times 8 is 40. And when I subtract, I get 0. So I know I'm totally done. This doesn't keep going. Sometimes you get a decimal that just keeps going forever, right? So if you were ever working on a homework or a test question, I think I tried to make sure that none of them kept going forever. Once you get if you get 2 or 3 decimal places and it's still going, just stop. Because some of them literally never end. I don't want you going out 15 decimal places and you're like, this still is going. Just stop. So 2 or 3 decimal places will be fine. Oh, and now remember my answer was going to be negative. So now at the top, do you remember the name of that? What's the answer to a division problem? That's called the quotient. Yes. So our answer is 18.35, but we established in the beginning it was going to be negative. Oops. There we go. There it is. Let's see if we can get one more done before lunch. Let's say we were going to do negative. I don't know why why it takes me forever to come up with these. How about 8.48, and we're gonna divide it by 0.2. So you might want to figure out the sign first. What would the sign have to be? Negative again. So then see if you, and that's a 0.2. So let me make it more clear. So you might start out with the 0.2 and then the 8.48. But before you begin, remember you got to get rid of that decimal on the outside. So take care of that first. Double check that you rewrote it to be this. Yeah. And then this one should be not that bad to do. This one kind of works out too nicely. Everybody got an answer? Go ahead, Jay. Negative 42.4 is right. So real quick, if you are still struggling with how to do these, I always start with the first digit. I ask myself, how many times does 2 go into 8? 2 does go into 8 nicely, 4 times. So I put a 4 up top. Ah, never mind. We'll finish after lunch. See you in a bit. Okay, so if we're trying to do this one, we had already asked ourselves, how many times does 2 go into 8? 4 whole times. So then I'm just going to take the number on the top, multiply it by the number in the front. 4 times 2 gets me 8. Subtract, I get a 0, but that's okay. I just keep going. Bring down that 4. How many times does 2 go into 4? Thank you, 2. So I put the 2 up top. 2 times 2 is 4. This is what I meant when I said that this one works out almost too nicely. They all kind of just work out. That one's gone. Drop down the last number 8. 2 goes into 8 4 times. And I'm left with a remainder of 0. So I know that I'm done. 42.4. And we had already figured out that that was going to be a negative. Okay, so there is a quick recap on dividing decimals. Now let's talk fractions. You ready? I got to flip the page. All right, fraction action. Dividing fractions. So let me give you a couple of step-by-steps real quick. As always, if any of them are mixed numbers, I'm rewriting them as improper. So there's that first step if you have to. And then you get to do your favorite saying, keep, change, flip. So that is the second step. Keep, change, flip. So I'm going to explain what I mean by that if you haven't heard that before. Keep first fraction.
Flip the second.
Change means you're going to change. It's going to be a division problem, right? We're going to change the division into multiplication. And then flip. That's when you take, do you remember that vocab word for a fraction that's flipped over? Like if you take 2/3 and you flip it over to 3/2, there's a special name for that word. Starts with an R. Do I remember? A fraction flipped over. It's called a reciprocal. So when we say flip, we mean flip the second fraction over. Because remember, the first fraction is going to stay as it is. You don't really touch the first fraction at all. Flip the second fraction over. I'm just going to add, that's called the reciprocal. So if you, if you hear that word, that's all it is. Reciprocal is just a fraction that's been flipped over. Once you do this keep, change, flip step, now it's a multiplication problem, just like you did yesterday. So now it becomes easy again. So division's not bad. You just have to do this part first. So do the keep, change, flip, and then it's like, ooh, I'm back on easy street because I know how to multiply fractions. So I'll just add that in as the third step. You're going to now solve as usual. So I'll give you a moment to get all that down, and then we'll do a couple examples. Okay, so let's try and see how this goes. So we'll start off easy. So let's do something like, how about 2/3 divided by, I don't know, how about 8/5? Something like that. So if I'm gonna do this, let's do keep, change, flip. So you're going to keep the first fraction exactly as it is. You don't do anything to that first fraction. So that one's going to stay as 2/3. I change the division into multiplication. And then I'm going to flip the second fraction over. So instead of having 8/5, now I have 5/8. See how that works? So that one literally got flipped over. And now I know how to do this. I know how to multiply. I just go straight across. So going straight across, I get 10. Straight across on the bottom, I get 24. And then I'm just going to reduce that answer like I normally would. So what goes into 10 and 24? What number divides into 10 and 24?
2.
Yep. So I'll get 5/12, right? I'm done. So dividing the fractions is just that easy. And then we just throw in the signs too, right? So if I had the same signs, it's positive. If it's different signs, it's negative. So let's try a trickier one. Say we did -3.5, and we wanted to divide that by, I don't know, 4/5. So according to our rule, step 1, I got to change it to improper. What would that number be? -3.5. What is that when you go improper? Actually, before we do that, what would the sign of my answer be? I'm gonna make myself an answer box here. What's the sign of this answer have to be? I need popsicle sticks. You guys aren't with me today. So in this example, Noah, what would the sign of the answer have to be? Yes. So I'm going to put a negative in the answer box, and then I kind of get to it. Forget about the signs. I don't have to worry about them anymore because it's already part of my answer. And we'll go from there. All right, Connor, what is 3.5 as an improper fraction? 7/2. Perfect. And I'm going to do 7/2 times, John, what would I put instead? I don't do 4/5. What do I do now? Yeah, so I keep the first fraction, I change division and multiplication. Nope. You're looking at the second fraction. We gotta do keep, change, flip. So what do you do at 4/5? Yeah, you gotta flip that over to 5/4. Now now it's a multiplication problem. So now it's easy. So multiply straight across. What do I get? Sophie. I'm multiplying straight across. What do you get? Over? Yes. Can you reduce that? I agree. So there's my answer. We already decided it was negative before, so we don't have to like come back and figure that out again because we already did it. I highly encourage you to do that. Draw yourself an answer box if you want. I'm thinking about the quiz. I wish I had them on there already, but I don't. So when you go to take the quiz, draw yourself an answer box because as soon as you know the sign, do that first and then you don't have to worry about it later. If you look back on the test you guys just took, there were so many times that I had to take off half a point because you were missing a negative. This way you won't forget about it and you won't lose all those points. Okay, Mrs. Sabia, does it get harder than this? Not really. I mean, I can try and trick you with something like this. What if you had -4 2/5 and I wanted to divide that by, let's say, -3? Okay, so let's start off. I'm going to draw myself an answer box. I'll put the sign in there just to help myself out. So, Suk, what would the sign have to be? What would the sign have to be?
Wouldn't it be positive?
It would have to be positive.
Yeah.
So I can put a plus sign in there just to remind myself I'm done with it, right? You can put that helps you. Now I can ignore the signs. We'll come back to them later. What's the next thing I have to do? Now that I've handled the signs, Ash, what would you do next? I know that's going to be a positive. So now what do I do? Change this to improper. Is that what you're saying? Yes, I got to change that next number to improper. So that's going to get me 5 times 4 is 20 plus 2 gets me 22/5. What do I write after that? J with an E. What would I write after that? Once I switch that to improper, now what? J with an E. Did you hear me? J with an E. What do I do next? Where do I go from there? I will, okay, so I can do that back up here. But, so I rewrote this one as 22/5. What happens to that division? What does that become? And then what do I do with this thing? Yes. So in our original, that was just the number 3. So if I want the reciprocal of that, if I want to flip that fraction over, it wasn't even a fraction. You can always make it a fraction by putting it over 1. So when you flip it over, it's going to be 1/5. third. Right? Do you see that? Now I can go ahead and multiply like I normally do. So J without an E, what would I get when I multiply straight across? Did you hear that I called on you?
Me?
Yeah,
Oh,
sorry.
I did it wrong.
That's okay. What if I'm gonna multiply straight across? What am I gonna get?
It would have been 22 or 15.
Yeah, thank you. I couldn't tell if you were working or if you didn't hear me. That's okay. So I get 22/15, and we already decided in the beginning it was positive, so I'm done. Oh, wait, I guess I should have asked myself, could I reduce this? No, I can't. Nothing goes into both. So does it get harder than that? Not really. I mean, that's the, what else could you do? You could do two mixed numbers, but it's still the same thing. Change them to improper, keep change flip. Anybody have any questions right now? No, we're all right? Okay, so let me decide what I want you to do next. Because I have this, but yeah, I don't know if I want to do that. Let me look here. I might go down this road. This might be better. All right, let me hole punch this. Yes, but we're gonna, well, now I'm kind of torn between what I want to. Oh, wait, today is just division. Oh, but this doesn't have any decimals on it. Huh. That's okay. I'll have you practice some decimals tomorrow in the beginning of class. We'll do it that way. All right, so let me give you this. And I'll tell you what I want you to do from here. It's part of it. Okay, can you please actually flip to the second page? You got one? Ash, can you hand? I think I give you two. Oh, did I not give you 1 second? Sorry. Oh. Shh, I guess. Didn't you borrow one from me yesterday? Did you ever give it back to me? I'm running out. Okay, so everybody look at the second page, a burning question. Okay, so let's read. We're gonna figure out this one. Why did Ray Fryer need to get an approval from Councilman Hugh before he could open a flower shop? I have no idea. So what do we need to do? We need to solve each one. So let's look at the very first one. Letter S. If you need to do your work on a different piece of paper, that's fine. Keep, change, flip, friends. So keep the first fraction, change to multiplication, flip that one over. And now if I multiply straight across, I get -6/7. Do you? Good. So what do? We look down at the bottom and we try and find -6/7 in there. Here's one, and we're gonna put a letter S above it. There's another -6/7. So make sure you look and find all of them. I think that's it.
Yeah, there's one in the corner, too.
Oh, yeah. Okay, get the idea? Not too bad. I'll do one more with you. How about we do one that's a little bit weirder, like letter N straight across. That one's got just a single number. So I'm gonna keep the first fraction, -7/10, change it to multiplication, and then what do I write when I flip 7 over? What's that become? 1/7. Multiply straight across, I get a -7/70. But you will not find that answer down below because you have to reduce this. So what does that become if you reduce it? What goes into 7 and 70? Yep, Jen. Yeah, 7 goes in. So we divide both, we get -1/10. Okay, so all the -1/10, let's put an N on those. Well, that was a good one. What is it, 3 of them? Oh, 4. Ooh. Okay. So that's it. So all I need you to do is submit just this page. I'll put it up on Jupyter in just a minute. You will never get credit for just the answer to the riddle. You could so easily Google the answer. It's, I'm never looking. I care more about, did you actually do the math? I like these puzzles though, because they are self-checking. You know right away if your answer's not down there, you know that something's not right. So I like them, but you can't abuse them. Yes, I know that the answers are Googleable. Don't do that. Okay, so give me a second. I'll open it on Jupyter for you. I'll also post the answer, the notes. Hi,
Savior,
what's up, Buttercup?
how are you?
Okay. Taking a break.
Why did the scarecrow?
That's a good one.
Because he was outstanding in his field. You get it? Thank you. Thank you for smiling.